1:47 a.m. Xichang Satellite Launch Center, Sichuan Province, China. 28 degrees north latitude, 102 degrees east longitude. The facility has been launching rockets since 1984. Its public mission is commercial and scientific satellite placement into geostationary orbit. Its less discussed mission, under the jurisdiction of the PLA Strategic Support Force's Space Systems Department, is the development, testing, and operational employment of the systems that can reach those same orbits for a different purpose. The SC-19 is a direct ascent anti-satellite missile. It is launched from a mobile ground platform, climbs to its target's orbital altitude on a guided trajectory, and releases a kinetic kill vehicle that impacts the target satellite at closing velocities that can exceed 10 kilometers per second. The kinetic energy released in that impact is sufficient to reduce a satellite bus of any size to thousands of fragments. It does not require an explosive payload. Physics provides the warhead. The DN-3 is a larger system, a two-stage rocket capable of reaching geosynchronous orbit at 35,786 kilometers altitude, the operating altitude of the space-based infrared system constellation. The SBIRS satellites that provide the United States its 7-second missile launch detection capability. The satellites that had been the first sensor to detect every adversary launch in every engagement scenario in this series. The satellites that served as the foundational layer of the entire U.S. strategic warning architecture. At 1:47 a.m., the first DN-3 launched from Xichang. It was not the only launch. Over the following 19 minutes, from 3 separate launch facilities, Xichang, Jiuquan in the Gobi Desert, and the mobile launcher positions on the Shandong coast, that the Strategic Support Force's Space Systems Department had been positioning for 11 days. The following launches occurred. 4 DN-3 intermediate-range ASAT systems, targeting the 2 operational SBIRS geosynchronous satellites, and 2 GPS Block 3 satellites in medium Earth orbit at 20,200 kilometers altitude. The GPS Block 3 satellites were not purely navigation assets. Their encrypted military signal provided the precision timing reference that synchronized every U.S. precision munitions guidance system, every Aegis ship's fire control radar, and every data link in the theater, a function that the civilian GPS signal could not replicate, and that the adversary's own Beidou navigation system, by no coincidence, was designed to operate independently of. 7 SC-19 mobile ASAT systems targeting the wideband global SATCOM satellites in geosynchronous orbit, the primary backbone of U.S. military communications in the Western Pacific and Indian Ocean theaters. WGS-7, WGS-8, and WGS-9 were the 3 satellites whose coverage arcs encompassed the Indo-Pacific theater. Without them, the carrier strike groups, submarine force, and land-based aviation that constituted U.S. military power in the region operated on backup communication systems with between 12% and 34% of normal bandwidth. Coordinating a multi-domain engagement under those conditions was not impossible. It had never been tested in actual combat conditions at scale. 3 additional SC-19 systems targeting the space-based space surveillance satellites that provided the U.S. its real-time orbital tracking capability. The systems that watched every object in orbit, and whose data was the prerequisite for any countermeasure against exactly the ASAT operation now underway. Total launches in the first 19 minutes. 14 ASAT systems across 4 target categories. The strategic logic was not primarily destructive. It was disruptive. The DN-3 could reach a geosynchronous satellite in approximately 8 to 11 hours from launch. The SC-19 could reach medium Earth orbit in approximately 3 hours. The launches were not timed to destroy the satellites before any ground response could occur. They were timed to create an irreversible commitment that forced the United States to choose within hours between 3 options: accept the degradation of its space architecture and continue planning operations without it, use its own counter-ASAT capabilities, and accept the debris field implications for shared orbital lanes, or engage diplomatically to pause the operation. A negotiating position that would require acknowledging the ASAT capability had worked as designed. The plan's assessment of which option the U.S. would choose had been a central element of the operation's political feasibility review. The assessment was uncertain. The operation had been approved despite the uncertainty, because the window created by the degradation, even a temporary window, even a 72-hour window while backup architectures were reconstituted, was assessed as sufficient for the operational phase it was designed to enable. 1:47 a.m. Buckley Space Force Base, Colorado. Space Delta IV Operations Center. The duty officer monitoring the geosynchronous orbital belt had 17 display screens arranged in a configuration that allowed her to track the position, telemetry, and health status of every U.S. satellite in geosynchronous orbit simultaneously. She had been in this position for 10 months. She had processed 3 previous anomalous launches from Chinese facilities, all of them test firings against target debris in lower orbits, each one attributed as a test within 40 minutes of the launch. At 1:47 a.m., the first DN-3 launch appeared as a ground-based radar track originating from the Xichang facility. The track's trajectory was not consistent with a commercial satellite insertion profile. It was consistent with a direct ascent trajectory toward the geosynchronous belt. She had the trajectory assessment confirmed by 2 independent tracking sources: the ground-based electro-optical deep space surveillance system and the space fence radar, within 3.4 minutes of first detection. At 1:50 a.m., with 4 confirmed launches and more appearing on the tracking picture, she transmitted the Space Attack Warning notification to U.S. Space Command, Strategic Command, and the National Security Council Watch Team. The notification format included one data field that the previous 3 anomalous launch notifications had not included: probable hostile intent. She had the authority to change that field's status. The previous 3 had been flagged as test. This one had 4 simultaneous launches targeting orbital altitudes consistent with U.S. national security space assets. The threshold for probable hostile intent was 4 or more simultaneous launches against assets of assessed strategic value. She changed the field at 1:51 a.m. The chain of events that notification initiated had no direct kinetic analog in the air and sea scenarios in this series. A Patriot battery did not launch against a DN-3. An Aegis ship did not fire against an SC-19. The U.S. response to a hostile ASAT engagement operated through different mechanisms, some kinetic, some non-kinetic, none of them capable of reversing the trajectories of weapons already in space. The first mechanism was hardening and repositioning. The surviving SBIRS satellites, the 4 in highly elliptical Molniya orbits that the DN-3's geosynchronous targeting profile did not reach, and the SBIRS GEO5 and SBIRS GEO6 birds, whose orbital positions placed them outside the primary engagement window of the 2 targeted SBIRS geosynchronous satellites, received maneuver commands at 1:54 a.m. Satellite maneuvers take time. A satellite in geosynchronous orbit cannot execute an emergency avoidance maneuver in minutes. It can execute a controlled orbit change over hours that displaces it from a predicted intercept trajectory. The 2 SBIRS geosynchronous satellites in the target set had 8 to 11 hours before the DN-3 kinetic kill vehicles reached their orbital altitude. That was sufficient time for a maneuver. Whether the maneuver would be sufficient to defeat the DN-3's guidance update capability was the question the Space Systems Command's Orbital Mechanics team was solving at 1:54 a.m. The GPS Block 3 constellation had more time. Medium Earth orbit intercept from an SC-19 ground launch was approximately 3 hours, and the GPS constellation's architecture distributed its 24 active satellites across 6 orbital planes, meaning that targeting any individual satellite degraded coverage in one region without eliminating global coverage. The plan's targeting had selected the 2 GPS satellites, whose combined coverage arc encompassed the Western Pacific and Indian Ocean theaters, maximizing regional degradation while minimizing the global provocation threshold. The wideband global SATCOM targeting was the operationally most immediate concern. WGS 7, WGS 8, and WGS 9 had no effective avoidance maneuver capability against a direct ascent ASAT on a 7-hour intercept trajectory from geosynchronous altitude. The SC-19 targeting these assets had been launched from the Shandong coast positions, a trajectory that took the weapon up through geosynchronous altitude at a crossing angle optimized to minimize the orbital mechanics team's maneuver window calculation. The engineering had been precise. At 2:11 a.m., 24 minutes after the first DN-3 launch, the National Security Council's emergency session received the Space Systems Command's initial assessment. If no countermeasures were executed, 3 WGS satellites would be intercepted within 7 hours, 2 SBIRS geosynchronous satellites within 9 hours, and 2 GPS Block 3 satellites within 3 hours. The GPS intercepts would occur before any diplomatic channel could be activated. The assessment also included the U.S. Counter-ASAT Capability Assessment. Classified. Not for this document. What was available in the Unclassified Response Framework? The ground-based laser system at Kirtland Air Force Base in New Mexico, whose primary function was space object tracking, but whose secondary capability, dazzling or disabling satellite sensors through directed energy without generating debris, provided a non-kinetic option against the attacking ASAT kill vehicles while they were still in ascent. The GBL's effective range against an ascending ASAT kill vehicle, assessed at 62% probability of sensor dazzle at ranges up to 2,200 kilometers from the facility. A dazzled kill vehicle retained its momentum but lost its terminal guidance. It would continue on its trajectory, but would not execute the final guidance corrections needed to achieve a precise intercept of a target satellite, whose position it could no longer track. Against a kinetic kill vehicle that derived its lethality from precision, sensor dazzle was not a neutralization. It was a trajectory deflection measured in fractions of a degree. At geosynchronous altitude, a fraction of a degree of deflection translated to hundreds of kilometers of miss distance. A kill vehicle that missed its target by 200 kilometers had achieved nothing. The GBL engagement authorization was requested at 2:14 a.m. and approved at 2:19 a.m. By 2:19 a.m., the SC-19 kill vehicles targeting the GPS Block 3 satellites were already at 1,400 kilometers altitude and climbing at approximately 4 kilometers per second. The GBL's window for dazzle engagement was narrowing with each passing second as the vehicles climbed above the effective engagement range. The GBL engaged the first SC-19 kill vehicle at 2:21 a.m. at 1,890 kilometers altitude, at the outer boundary of its effective engagement range. Probability of effective dazzle at that range, 44%. The laser maintained continuous illumination on the vehicle for 9 seconds as it climbed through the beam's optimal engagement zone. The orbital mechanics team's post-engagement trajectory analysis at 2:41 a.m. assessed the first GPS Block 3 kill vehicle as deflected by 0.7 degrees from its pre-engagement trajectory, sufficient at the 20,200 kilometer target altitude to produce a miss distance of approximately 246 kilometers. The GPS Block 3 satellite was assessed as safe from this vehicle. The second SC-19 kill vehicle had been launched from a Shandong coast position, whose azimuth placed it in a trajectory that took it over the Pacific, outside the GBL's geographic coverage arc from New Mexico. The second GPS Block 3 satellite was not engageable by the Kirtland facility. The NSC was informed at 2:22 a.m. that one GPS kill vehicle had been deflected, one had not, and the WGS and SBIRS targeting DN-3 and SC-19 vehicles were beyond the GBL's engagement geometry. The cyber component of the response activated at 2:24 a.m. USCYBERCOM's Space Mission Force had been monitoring the Xichang and Jiuquan launch facility network infrastructure since the elevated alert had been issued 9 days earlier. The pre-positioned access into the Xichang facility's launch sequencing system had been established through a supply chain intrusion into the facility's industrial control software 14 months prior. The access provided visibility into the facility's launch calendar and, in certain configurations, the ability to inject anomalous sensor data into the launch vehicle's pre-launch health monitoring system. The operational decision to use the access had been deferred for 9 days because activating it would reveal the implant's existence, and the implant's value as a persistent intelligence source was assessed as exceeding its value as a single-use disruption tool. At 2:24 a.m., with 4 ASAT vehicles already in flight and additional launches still pending from the Jiuquan facility, the value calculation changed. The Jiuquan facility had 3 additional SC-19 systems scheduled for launch in the next 40 minutes, targeting the space-based space surveillance satellites. The USCYBERCOM operation injected falsified telemetry data into the Jiuquan launch sequencing system at 2:26 a.m., causing 2 of the 3 scheduled launches to be automatically held by the facility's own health check software, which had received sensor data indicating a hydraulic pressure anomaly in the launch vehicle's second-stage interface. The anomaly was not real. The hold was. One of the 3 SBSS targeting launches proceeded normally. It had been pre-staged on a separate control loop that the implant did not have access to. 2 of 3 additional SBSS targeting launches held. 1 launched. The total ASAT launch count was reduced from the operation's planned 17 systems to 14 by the cyber operation. 3 launches had been prevented from occurring. The 3 that had been prevented included both remaining GPS targeting SC-19 systems and 1 additional WGS targeting system that had been sequenced for launch at 2:31 a.m. The GPS constellation's regional coverage degradation was now limited to the 1 kill vehicle that the GBL had not been able to deflect. The WGS satellite targeting had been reduced from 3 to 3 original -1 cyber-held. 2 WGS satellites remained in the target set rather than 3. At 3:14 a.m., USS John Finn, an Aegis destroyer participating in an exercise in the Central Pacific, received authorization to employ its SM-3 Block 2A in an anti-satellite role against the SC-19 kill vehicle approaching the GPS Block 3 satellite that the GBL had not deflected. The SM-3 Block 2A had been tested in the ASAT role once previously, the 2008 Operation Burnt Frost engagement against USA-193, and had a validated capability against targets in low Earth orbit. The GPS Block 3 satellite at 20,200 kilometers was at 4 times the altitude of the Burnt Frost engagement. The SM-3 Block 2A's certified operational ceiling against satellite targets had not been publicly disclosed. The authorization had been granted under a classified operational parameter that the engagement met. USS John Finn fired at 3:17 a.m. The SM-3 kill vehicle reached the intercept geometry at 3:44 a.m., 27 minutes of flight time. The engagement outcome was assessed at 3:46 a.m. The SC-19 kill vehicle had been intercepted at 18,400 kilometers altitude, 1,800 kilometers below the GPS Block 3 target satellite's orbital position. The GPS Block 3 satellite survived. The orbital debris from the SM-3 intercept of the SC-19 kill vehicle at 18,400 kilometers was assessed as a manageable addition to the catalog debris environment at that altitude. A kill vehicle intercepted before reaching its target generates debris at the intercept altitude rather than the target altitude, better than an intercept at the target satellite's orbital plane, which would have seeded the GPS operational orbit with fragments. The two DN-3 vehicles targeting the SBIRS geosynchronous satellites were still in flight at 3:46 a.m. They would not reach geosynchronous altitude until approximately 9:30 a.m. The SBIRS satellite's commanded maneuvers had been executing for 90 minutes. The orbital mechanics team's assessment at 3:51 a.m. SBIRS-GEO-3's maneuver was assessed as sufficient to produce a miss. SBIRS GEO-4's maneuver trajectory was marginal. The DN-3's guidance update capability might compensate for the maneuver. Probability of successful intercept against GEO-4, despite maneuver, 38%. A 38% probability of losing a satellite that had been the earliest warning sensor for every adversary missile launch in the region. The diplomatic channel had been activated at 2:31 a.m. through the established U.S.-China Crisis Communication Hotline. The communication had been received. No response had been provided as of 3:51 a.m. The operational consequence of the space engagement was already visible in the military communications picture. The single WGS satellite that had been held by the cyber operation, but whose replacement launch at 2:31 a.m. had ultimately proceeded. WGS-7's targeting vehicle was still inbound, would reach its target at approximately 8:47 a.m. Until then, the WGS constellation was operating at full capacity. After 8:47 a.m., if the intercept succeeded, the Indo-Pacific theater's military communications would drop to approximately 71% of normal bandwidth capacity. Manageable. Degraded. The carrier strike groups in the Philippine Sea, the submarine force, and the air wings operating across the theater had been notified at 2:21 a.m. of the pending space architecture changes. They were conducting their current operations with the awareness that within 7 hours, a portion of their communications and precision navigation infrastructure would be degraded. The operational tempo had shifted accordingly, accelerating actions that depended on full GPS precision, deferring operations that could tolerate delay, pre-positioning human-operated targeting solutions for engagements that had previously been fully automated. The machine was adapting. It was slower. The adaptation was what the plan had expected to exploit. 4:09 a.m. U.S. Space Command Operations Center, Peterson Space Force Base, Colorado. The duty general had been at his console since 1:52 a.m. Across his display, 14 ASAT vehicles were tracked in various phases of ascent or transit toward their targets. 2 had been neutralized: the GBL deflected GPS vehicle and the SM-3 intercepted GPS vehicle. The cyber operation had held 3 additional launches. Of the original planned 17, 9 remained on active intercept trajectories. 5 of those 9 were the WGS and SBSS targeting vehicles that no current U.S. countermeasure in the active employment timeline could reach. He had 4 countermeasures still available. 3 were classified. 1 was diplomatic. The diplomatic channel had not produced a response in 2 hours and 18 minutes. He noted the timeline in his log. He transmitted the 4-hour degradation assessment to every theater command simultaneously. He authorized the deployment of the backup satellite communications relay constellation, a set of 8 smaller SATCOM microsatellites launched 18 months earlier specifically for post-disruption continuity, now commanded to activate their crosslinks and begin providing reduced bandwidth military communications coverage as a bridge between the primary WGS architecture and any degraded post-engagement configuration. The microsatellites came online at 4:14 a.m. Their combined bandwidth was 22% of the WGS primary constellation's capacity. It was enough to maintain basic command and control continuity. Time from first DN-3 launch detection to completion of all authorized U.S. countermeasures. 2 hours, 27 minutes. Plan ASAT systems launched. 4 DN-3 targeting SBIRS, GEO, and GPS, Block 3. 7SC-19 targeting WGS. 3SC-19 targeting SBSS. Total, 14 systems, 3 additional held by USCYBERCOM cyber operation, planned 17. US countermeasure results. GBL dazzle of GPS-SC 19 kill vehicle, successful, 246 kilometers miss distance. SM3, Block 2A intercept of second GPS-SC 19 kill vehicle at 18,400 kilometers, successful. USCYBERCOM hold. 3 of 3 targeted Jiuquan launches held. GBL and SM3 not available for WGS or SBSS targeting vehicles. No engagement executed. Projected satellite impact timeline, pending maneuver assessment. WGS 7, 8:47 a.m. WGS 8 to 9, 12 a.m. SBSS 1, 7:44 a.m. SBIRS GEO 3, maneuver assessed as sufficient, probable miss. SBIRS GEO 4, maneuver marginal, 38% intercept probability. Reassessment ongoing. 2 GPS Block 3, both preserved by countermeasures. Communications assessment, post-projected impacts. Indo-Pacific theater military bandwidth at approximately 71% if WGS 7 intercept succeeds, 58% if WGS 7 and WGS 8 both intercepted. GPS precision navigation, full capacity preserved by GBL and SM3 countermeasures. SBIRS early warning, dependent on GEO4 maneuver outcome, assessed at 6 to 9 hours. Backup microsatellite constellation, online at 4:14 a.m., providing 22% bandwidth bridge. The plan had launched 14 ASAT systems. 3 had been held by cyber operation. 2 GPS targeting vehicles had been defeated by GBL and SM3. The remaining 9 were in flight toward targets that no currently employed U.S. countermeasure could reach. The GPS constellation had been preserved. The communications and surveillance degradation was still inbound. The machine had not been broken. It had been slowed. The 38% probability assessment for SBIRS GEO4 was the number that would define the next 6 hours of the Space Command's operational focus. A 38% probability of losing the satellite that had provided the first 7-second warning of every missile launch in the region was not a 100% probability. It was also not a number that allowed any activity that depended on that 7-second warning to proceed without contingency planning for its absence. 7 seconds. The entire architecture of Western Pacific defense had been built around that detection interval. It had been present, functioning, and uncontested in every engagement in this series. In 6 hours, it might not be. The backup systems existed. The constellation had redundancy. The warning function would not disappear entirely. It would be slower, less certain, dependent on ground-based radar rather than space-based infrared. Against an adversary whose missiles had been detected 7 seconds after ignition for the preceding decade. A transition to a system that provided 90-second warning after radar acquisition was not catastrophic. It was a regression to the architecture of 2009. The adversary had modeled what the U.S. could do in 7 seconds. It had designed an operation around what the U.S. could do in 90. The 7-second interval was the capstone achievement of 30 years of space architecture investment. The plan had built 14 missiles specifically to take it away. 2 had been stopped. 12 were still in flight. The next assessment cycle was in 47 minutes.